Okay, so my last video I got cut off, so let's finish on this problem here. So we talked about the 270 plus this theta is what's going to give me my bearing. And so this is going to be my opposite, and this is my adjacent. And so again, we have tangent here. So we have the tan um, of theta is equal to 200 over 100, which is really the same thing as just 2. Um, so we have the inverse tangent on both sides, gets rid of our tangent. So theta, when we plug that in, is 63.4 degrees. And so we have our 270 degree plus our 63.4 gives me a bearing of 333.4 degrees. Another way you could do that is think of your entire 360 degree. If we just subtract out um, that chunk, you could do that as well. But because we have to go clockwise, it makes more sense to do your 270 plus your theta there. And that is Julia's bearings from her starting point. Okay, so let's take a look at the next example. So we have a courier that departs from Depot A and drives 136 degrees for 2.4 miles, and then intersection B. And then he turns right, which means B is a right angle, and drives 266 degrees. Okay, so let's take a look and get this diagram. Here we are at A, and that's where he starts. And think of our bearing, it's north. And he drives, it says 136 degrees. So it's not quite a straight line. So this right here is going to be 136 degrees. And there's our line. And that's for 2.4 kilometers to, make that a little bit bigger, to B. And then it says B is he turns right at the intersection. So that means that that is a right angle right here. And again, if you think about your true north, it says he drives a 226 degree. So that would be 180. So then 226 is going to be a little bit further than that. So that's a 226 degree bearing. And he drives that for 3.1, and he ends up at C, which is his destination. And because he turned right, we know that that is a right angle right there. And it is asking us to find the distance from from C to A. So we have a right triangle here. So we have 2.4 squared plus 3.1 squared equals C squared. We'll just label that as C. And when we add those two together, we get 15.37 is equal to C squared. So if we square root both sides, so then the distance from A to C, so we'll say AC is, we're just keeping it, we'll just keep it at 15.37. That's the whole entire number. If you want to round it 3 sig fig, it'd be 3.92 kilometers, 3 sig fig. Okay, so that's the first part. And then part B says the bearing of C to A. And so our bearing of C to A is going to be, if you think about your due north, we're going to be looking at this angle, right? Or no, that's not the angle we're going to be looking at. We're looking for that angle right there from C to A. Okay, so if we look at that, we've got our opposite and our adjacent. And so, and I'm using opposite and adjacent because those are what was given to us. This is a rounded value there. So we have the tangent again of theta is equal to 3.1 over 2.4. And then we have to do our inverse tan on both sides. And when we do that in our calculator, we get 52.3 degrees. And so if we add our 136 plus 52.3, we get a bearing of 188.3 degrees. And that is how we do true bearing.